Okay, today we're going to talk about comparing properties of matter. And so we're going to take the properties across three different types of bonding, right? Ionic, metallic, and covalent. We're also going to talk about physical versus chemical properties. And so let's start off with what is a property? And so it's just going to be a characteristic or trait of a substance. So any type of descriptor that we can use or anything we can say to describe a compound or a substance. Okay, and there are two overall classes of properties or two types, and that's physical and chemical. And so we've seen some already between labs and other notes. And so physical properties are any property that can be observed without changing what it is we're talking about. So the substance, we're not going to alter it when we are observing the physical properties. And so when we're looking at that, it's saying it something like mass, melting point, boiling point, density. Okay, we could take the mass, put it on put it on a balance without having to alter it. We can measure its density, right? Mass versus volume without having to change it. Melting points and physical points, you might think at first that it changes the substance, but it really doesn't. It just changes its state of matter. When you have ice and you melt it and it's water and then you boil it and it becomes vapor, the whole time it's still H2O. We haven't altered that the chemical composition. All right. Whereas with chemical properties, in order to observe them, you have to change the chemical composition. And so that'd be things like flammability. The only way that we can test if something's flammable or observe it is to burn it. And then it's no longer what we were talking about. Same thing, toxicity, uh, reactivity, stability, any of these things, the only way to test them is to alter the chemical composition. Essentially, turn it into something else. All right. And so those are the differences. Physical is just by looking at it, touching it, you know, playing a little bit with the properties like melting point or boiling point, whereas chemical is undergoing those reactions. All right. So let's take a look at two different types of physical properties, intensive and extensive. And intensive properties is going to be a physical property of a substance that doesn't depend on the amount of matter present, whereas extensive does depend on the amount. So extensive is the easier one to start off. It depends on how much you have. So mass, volume, the size. If you measured like something like the length, all these things are dependent on how much you have, right? If you have more of a substance, the mass is going to change. It's going to go up. And so that is extensive. Now, intensive are going to be the things like the boiling point, melting point, color, texture. They do hardness and luster, right? All of those things are intensive properties. It doesn't matter how much you have, all right? It's going to have the same boiling point. It's going to have the same color, whether you have a little bit of it or a whole lot of it, okay? And one property that gets a little confused here is density, because density, in order to calculate, you have to have mass and volume, which are both going to be extensive properties. But density itself is intensive. Essentially, it's a ratio between those two, and it won't change no matter how much of them you have. You can up the mass, but then you'll also have to up the volume because if you have more matter, it's going to take up more space. But the ratio at which is always going to be the same. And so density would be intensive. Now, on the flip side, some chemical properties are things like toxicity, the oxidation states, heat of combustion, or stability, flammability, reactivity, uh, actual bonding properties. Okay, these are all things that, in order to observe them, we have to change the compound. We have to react it, and so because of that, those are going to be chemical properties. Now, if we look at some properties of the different classes, so when we talked about the periodic table, we talked about the classes of elements that you have metals, on the left-hand side with the exception of hydrogen, and nonmetals on that top right-hand side. And then right in between them, you had this little sliver that was the metalloids. And so some general properties that we're going to see. And we talked about a few of these like ductility and malleability, right? Metals are shiny, they're good conductors of electric and heat. All right, we talked about a lot of these, some examples, right? You have sodium, silver, strontium, iron, copper, cobalt, gold, okay? Lead, all these things are going to be metals. And if we remember correctly, ductile, we can pull it into wires, and malleable, we can bang it real thin, bend it, and it will still maintain its strength even though it's very, very thin. Now, on the other side, our non-metals are going to be dull, they're going to be brittle, and they are going to be good insulators because they're poor conductors. If you don't conduct electricity or heat, then you're an insulator. So metals are good conductors, non-metals are good insulators. The example of those nonmetals, chlorine, neon, carbon, oxygen, sulfur, all those things upright, and hydrogen. Always remember hydrogen, although it's on that left-hand side, is a nonmetal. And then right in between, right down the staircase there, are the metalloids. And they exhibit the properties of both. They can go back and forth depending on what they're with. All right, you put silicone with oxygen, it makes glass, which is brittle. It's an insulator. Okay, but if you put it with some metals, you're going to have where it becomes a conductor, right? All kinds of stuff. So your example there, silicon, boron, those are right on the line there, exhibit both properties. Okay, now there were three different types of chemical compounds that we can have some properties for, and that's ionic, molecular, which is covalent, and metallic. And so with our ionic bonding, we know it's going to transfer those electrons. All right. We know that it forms those crystalline solids. It has a high melting point. It is, in fact, brittle, right? Those will crack. They will break. They will not bend. All right. And when they're in solution, the ones that do dissolve will form an electrolyte, will conduct electricity in solution. All right, so those are our ionic bonds. A lot of our salts are ionic bonds, right? Sodium chloride, magnesium chloride. You get into the lead nitrates, right? They have a metal with a non-metal. All right, that makes us ionic, metal with a non-metal. And then you have molecular. So now you have your covalent bonds. And those things share electrons, right? They both want to gain, therefore they share. And so they have low melting points. All right, they produce molecules in solution, so they are not electrolytes. Okay, they vary greatly. We can't give it a uniform property. Some will dissolve, some won't. They have that polarity, the intermolecular forces that really determine a lot of the properties of those compounds. So every time you're looking at it, you need to evaluate, well, what is the compound? Is it polar? Does it have intermolecular forces? And then what are we going to do with it? Like dissolves like. So if it's a polar molecule, it will interact with polar molecules. If it's a nonpolar, it'll interact with nonpolars. That's why oil and water don't mix. Oil being nonpolar, water being polar, they will separate. They will not mix. Okay, and then you have metallic compounds, which are those, they also share the electrons, but in a different way. Instead of that covalent bond where they kind of overlap and share it in the middle, metallic bond has that sea of electrons. The electrons are shared throughout, and they have these cation cores. All right, and those things will be ductile, malleable, shiny, are metals that we just talked about. All right, so that's kind of a quick summary, guys, a brief summary of our varying properties. All right, get used to evaluating what the compounds are, like ionic or molecular or metallic, and that'll give you some insight into the property, which will help you to figure out what reactions they might undergo, or what things you can use to your advantage in a laboratory setting, ways you can identify them. Is this ionic or molecular? Well, let's look at the properties and use a defining feature. All right, is it molecular or metallic? Well, let's take a look at its features and its properties and see, is there a test that can tell the difference? And then once you're into there, well, how can you go about identifying the different ones? But this is the overall view, properties start to finish.